My report for lab 2. Purpose of this lab is to figure out the charge on a single piece of tape that has been charged by pulling it off another piece of tape, and we do that using multiple models. In lab 1, we used a model that treated the tape as if all of its charge were concentrated at a single point at the center of the tape. In this lab, we do it where we assume that all of the charge is concentrated in point charges, which are evenly distributed along the length of the tape, and I did an extra thing. I did it where I assumed it was distributed across an area evenly that's like a rectangle. And the principles we do to figure this out are Coulomb's law, Newton's first law, and a sneak peek of my results is I got for the line charge model, I got 3.5 times 10 to the negative 8 coulombs, and for the rectangle charge, I got 2.5 times 10 to the negative 8 coulombs. So Coulomb's law tells us that the force on an object it tells us the force on an object based on the charge of the object, the charge of the object acting upon it, and the distance between these objects. And by using this in combination with the fact that the levitating tape means that it's not moving and therefore has no net force by Newton's first law, we can calculate the charge on a piece of tape. So the models we used are the line charge model and the rectangle charge model. The line charge model is used because it's slightly more accurate representation of what's actually going on than the point charge model, because charge is like actually distributed across the length of a piece of tape, and the rectangle charge model is used because it's even more accurate. Like if you crank up the n high enough, it's like actually what's going on the piece of tape. You've got a bunch of point charges that are distributed across it. And we do need to make some assumptions for these models to work. We have to assume that air resistance and the force of the book on the tape are both negligible. We have to assume that gravity is 9.81. We have to assume that the charge is evenly distributed across the tape. And we also kind of have to assume the weight or the mass, I guess, of the tape, because you can't really measure a piece of tape that is that small. At least I can't with the stuff I have. So the experiment goes like this. You take a piece of tape, you charge it by ripping it off of another piece of tape. You suspend it between two level surfaces, like two stacks of books. You charge another piece of tape in the same way, so that you can assume that they both have the same charge. Then you bring the second piece of tape under the first one until the first one like stops hanging and starts levitating. And then you measure the distance between the two pieces of tape, and you use that to calculate like what the charge has to be to cause the force to be zero. So the code simulates the tape as a bunch of point charges, and it does that both in a line. Mine does that both in a line and in a rectangle. And then it adds up the forces of the point charges on the bottom tape on the point charges on the top one. So like every point charge on the bottom tape exerts some force on every point charge on the top, and it adds all of those up to get a net force, and then it compares that to the force of gravity, and makes sure they're zero. So for the results, because the force varies with the square of the charge. To get the charge, you can vary it with the square root of like the ratio of just guessing, and then ratio, like the square root of the ratio there. So that's how I got these charge numbers. If we were using a point charge model, we would get, as you can see here, a good bit lower of a charge, and that's because you need less charge to create the same amount of force with a point charge. Because if you think about like a line charge, the charge on the left of the bottom one is going to have a lower force on the charge on the right of the top one, because it's a much further distance than it's going to have on the charge on the left of the top one. Whereas in a point charge, it's all concentrated, it's all going to be the minimum distance, and it'll have like a higher force with the same lower charge. So it'll need a lower charge to create the same force.